Welcome to this video covering sections 9.1 to 9.2. I've made this video in an attempt to compensate for the lack of class time we have all had together recently due to my absences and the absences of many of you. This is the first of 3 videos that I will post this weekend. For this unit on optimization, there are a few geometrical facts that you will need to become comfortable with. Based on the handout that you received and should have completed, entitled 9.1 and 9.2 Determining Optimum Area and Perimeter, you should have discovered that for a given perimeter, the rectangle with the maximum area is a square. In the handout example, Lieberman students had 24 1-meter sections of fencing to put around a garden. They wanted the garden to have the largest area possible. Through the investigation using the chart you can see here, you should have discovered that the dimensions of a rectangle that create the largest area make a square. You can see that here on the chart where the width is 6 meters and the length is 6 meters. So this section right here. Making the chart like the one shown here, every time you were given this kind of question would not be a very efficient way to handle these problems. Since you know that a square will have the maximum area for a given perimeter, and you know that a square has 4 congruent sides, you can, first, divide the perimeter by 4 to determine the length of each side. Now that you know the length of each side of the square's side, you can square the quotient to find the area of the square. You end up with a square like the one shown here, which has a side length of 6 meters and an area of 36 meters squared. In this question from your assigned homework on page 488, you are asked to determine the maximum rectangular area that can be enclosed with 20 or 40 sections of fence that are 2.8 meters in length. Here we will just focus on question A. To answer this question, you can use the method that I just described with one small adaptation. First, you will need to divide 20 by 4 to find how many sections of fence each side will have. Then, and here's the adaptation, multiply by 5 by 2.8 to find the length of each of the square's sides. Lastly, square the length of the square side to find the area. Thus, the maximum rectangular area that you can enclose with 20 pieces, which are 2.8 meters in length, is 196 meters squared. You should be able to, based on this, do question B on your own. In the handout 9.1 and 9.2 Determining Optimum Area and Perimeter, you should have also discovered that when you have to create only 3 sides of a border, the rectangle with the maximum area has a length that is twice the width. This fact can be seen in the chart when the width is 25 meters and the length is 50 meters, making the area 1,250 meters squared. That can be seen right here in the chart. Again, making a chart like this is very inefficient. A more efficient method for finding the dimensions and the area of a rectangle with only 3 borders is to 1. Divide the given perimeter by 2 to find the length of the rectangle. So if I'm looking from above and I'm only making the gray parts of the rectangle that you see here, I have identified that this side here is 50 meters. Next, I would divide the quotient by 2 to find the width of the rectangle. Now I have found the width of the rectangle, which, if you look on our diagram here, is this side over here. Lastly, I would need to determine the area of the rectangle using the area formula for a rectangle, A equals length times width. This gives me the result of 1,250 meters squared. In this question from your assigned homework, you are asked to create a fence against an existing wall with the same sections of fence from question 5. Remember that each section of fence is 2.8 meters in length. Here we will only focus on A, and you should be able to figure out B on your own. Again, to answer this question, you can use the method I just described with one small adaptation. First, divide 20 by 2 to find how many sections of fence the length will have. Then, divide the quotient by 2 to find how many sections of fence the width will have. Then, and here's the adaptation, multiply 10 by 2.8 and 5 by 2.8 to find the actual lengths of the length and the width. You now have a wall that has a length of 28 meters and a width of 14 meters. Lastly, you need to determine the area of the rectangle by using the area formula for a rectangle. You end up with a rectangle that has an area of 392 meters squared. Another fact that you should have discovered is that for a given area, the rectangle with the minimum perimeter is a square. This fact can be seen in the chart where the width is 6 meters and the length is 6 meters. So that is right here in our chart. As I've already noted twice before, making a chart like this is not efficient. Since you know that a square will have the minimum perimeter for a given area, and you know that a square has 4 congruent sides, you can first square root the given area to find the side lengths of the square. Now that you know that the side length is 6 kilometers, you can now use the formula for the perimeter of a square to find its perimeter. As a result, I get a rectangle, in this case obviously a square, that has a perimeter that is 24 kilometers. To recap, the 3 geometrical facts that you should be aware of and utilize to solve problems are: for a given perimeter, the rectangle with the maximum area is a square. However, when you have to only create 3 sides of a border, the rectangle with the maximum area has a length that is twice the width. And lastly, for a given area, the rectangle with the minimum perimeter is a square. This is the first of 3 videos that I will create this week, and that will cover sections 9.1 to 9.6. Stay tuned and keep checking your Google Classroom feed.